All right, guys, we are going to start reviewing for the second test of the second quarter. It's going to be on Wednesday, December 11th. For number 1, determine when the expression is undefined. Undefined is just when the denominator equals 0. Doesn't matter what the numerator is at all. So 2x squared minus 9x minus 5 equals 0. You can do quadratic formula. You can do completing the square. I'm going to factor it. If you factor this, you should get 2x plus 1 times x minus 5 equals 0. So that's after doing master product, which means that this expression is undefined when x is equal to negative 1 over 2 and x is equal to 5. If you plug either one of those into the question, you get 0 in the denominator, which you cannot have. For numbers 2 and 3, simplifying the rational expressions. So simplifying, you are going to just factor the top, factor the bottom, see what cancels out. So for number 2, x squared minus 9, using the difference of two squares, that is x plus 3 times x minus 3, divided by, on the bottom, 2x squared plus x minus 15, you would do master product on, so two numbers that multiply to be negative 30, add to be a positive 1. That factors to be 2x minus 5 times x plus 3. So these x plus 3's cancel out. So this expression, simplified, is equivalent to x minus 3 divided by 2x minus 5. Same idea with number 3. 2x minus 10, you take out a GCF of 2, you're left with x minus 5. On the bottom, 25 minus x squared, that's another difference of two squares. So the square root of 25 is 5, square root of x squared is x. You have 1 plus, 1 minus. Now, though, this is that rule that we were talking about. X minus 5 and 5 minus x are not the same thing. So to cancel them out, you have to replace one of them with a negative 1. I always replace the top factor with a negative 1. You can do whichever one you want. So this is negative 2 divided by 5 plus x for number 3. For number 4, determine the result when f of x is divided by g of x. Express the result in the form. So this just means the quotient plus the remainder over the divisor. So for number 4, when I do 3x plus 1 divided by this whole thing, all of my exponents are included. It's a minus. All of my exponents are included, and they are already in descending order. So I don't have to manipulate the dividend at all. 3x to the third divided by 3x is x squared. I multiply that back out. So this is 3x to the third plus x squared. I put this in parentheses and I subtract. 3 minus 3 cancels. Negative 29 minus 1 is negative 30x squared. And I bring down the negative 16x. That's one round. If you can do it once, you can keep going. So negative 30x squared divided by 3x is negative 10x. I multiply that by the divisor. So negative 30x squared minus 10x. I put this in parentheses and I subtract. Negative 30 minus negative 30 cancels as it should. Negative 16 minus negative 10 is a negative 6x. And I bring down the next term, which is a minus 8. Negative 6x divided by 3x is negative 2. That gives me negative 6x minus 2. I put this in parentheses and I subtract. Negative 6 minus negative 6 cancels. Negative 8 minus negative 2 gives me a negative 6. So the answer, though, I still have to rewrite it, is x squared minus 10x minus 2 plus negative 6 over 3x plus 1. You could also write this as x squared minus 10x minus 2 minus 6 over 3x plus 1. It's really the same thing. Okay, but that's long division. For number 5, I'm going to do the same thing. Again, all of my exponents are included in descending order, so I don't have to manipulate the dividend and put in any placeholders or anything like that. Okay, 8x to the third divided by 4x is 2x squared. I multiply that back out. I get 8x to the third plus 2x squared. Put that in parentheses and subtract. 8 minus 8 cancels. 30 minus 2 is 28x squared. Bring down my next term. 28x squared divided by 4x is a positive 7x. I multiply that out. 28x squared plus 7x. I put that in parentheses and I subtract. 28 minus 28 cancels. 3 minus 7 is negative 4x minus 1. Negative 4x divided by 4x is minus 1. So I get negative 4x minus 1. Put that in parentheses. I subtract. Negative 4 minus negative 4 cancels. Negative 1 minus negative 1 also cancels. I get a remainder of 0. So the quotient, or the result, I still have to write 2x squared plus 7x minus 1. So the difference between 4 and 5 is that in number 4, you get a remainder of negative 6, and in number 5, you get a remainder of 0. That means in number 4, because you have a remainder that is not 0, that means that 3x plus 1 is not a factor of 3x to the third minus 29x squared minus 16x minus 8. Okay? In number 5, because you get a remainder of 0, 4x plus 1 is a factor of 8x to the third plus 30x squared plus 3x minus 1. Okay, the question didn't ask me to figure that out, but you should still know that. Okay, in number 6 and 7, determine the remainder when f of x is divided by x plus 2. Number 6, you could do long division if you wanted to. Number 7, you can if you can get the equation, which it's just a parabola that's shifted down 3 units. But you don't technically have an equation for number 7. So I'm going to show you, we talked about this in class. If we head back up to number 4 and 5 for a second. Number 4, you were dividing by 3x plus 1. So I'm going to put that here. If you set that equal to 0 and solve, you get x is equal to negative 1 over 3. If you remember in class we did this. That means that this equation, this f of x, this function, contains the point negative 1 over 3, comma, the remainder, negative 6. For number 5, this function here, f of x, contains the point 4x plus 1 equals 0, so x is equal to negative 1 over 4, contains the point negative 1 over 4, comma, 0. So you can use that in number 6 and number 7. So for number 6, determine the remainder. So when we're dividing by x plus 2, so x plus 2 equals 0. So x is equal to negative 2. So I need to figure out the point when x is negative 2. So I do f of negative 2 equals 5 times negative 2 to the third minus 8 times negative 2 minus 1, which gives me negative 25. So the y value is negative 25, which means the remainder is negative 25. Which means that x plus 2 would not be a factor of f of x for number 6. For number 7, it's the same idea, just with a graph. So again, x plus 2, we want to see the remainder when it's divided by x plus 2. So I need to look at the y value when x is equal to negative 2. So I go to negative 2, which is right here. It hits the graph up here. So that point is negative 2 comma 5, which means that the remainder is equal to 5. So x plus 2 is also not a factor of this function, which we already know because it doesn't hit that point right there, which is negative 2 comma 0, which means that the y value, the remainder should be 0 if it's a factor, which it's not. For numbers 8 and 9, these are our rational equations. So the first step, in this case you really don't have to for both 8 and 9. Your first step really should be to factor the denominators to see what your LCD would be. In this case though, our LCD is easily going to be x plus 2x minus 2. So I'm going to put that on top of all of my fractions. Okay, in my first fraction, the x plus 2's cancel. I am left with 3 times x minus 2 plus, here x minus 2's cancel. I'm left with 2 times x plus 2 equals, x minus 2 cancels, x times x plus 2. So this is 3x minus 6 plus 2x plus 4. equals x squared plus 2x. This is 5x minus 2 equals x squared plus 2x. It's a quadratic. I'm going to set it equal to 0. So if I subtract the 5x, I get negative 3x. If I add the 2, I get plus 2. And then I have 3 options. I can do quadratic formula, completing the square, or you could factor it. I always try to factor it. So I factor it using master product. I get x minus 2 times x minus 1 equals 0, which gives me x equals 2 and x equals 1 as my 2 possible answers. But then you have to plug your answer choice in to the denominators and see if it cancels out. So when I plug 2 in to x minus 2 and x minus 2, I get a 0, which means it's undefined, so x cannot be equal to 2. So my only answer for number 8 is x equals 1. You have to reject your answers if they don't work to get full credit for this. For number 9, my LCD would be x plus 1 times x minus 1. This one's a little bit tougher. I'm sure you'll see why in a second. So the x plus 1's cancel. I have 2x plus 5 times x minus 1. So this is why it's tougher, because you have to double distribute. Plus x minus 1's cancel, so I have 3 times x minus 1 equals x minus 1's cancel. I have x plus 2 times x plus 1. So this is 2x squared minus 2x plus 5x is plus 3x minus 5 plus 3x minus 3 equals x squared plus 3x plus 2 after I double distribute. 2x squared plus 6x minus 8 equals x squared plus 3x plus 2. Set it equal to 0. There's a mistake in here. This should have been x plus 1, so this would be plus 3, which means that this would be minus 2. There we go. Minus 2. So when I subtract the 2 over, I get minus 4 equals 0. So that's my quadratic that I'm solving. Sorry. So I'm going to factor it by doing master product. I get x plus 4 times x minus 1 equals 0, which gives me x equals negative 4, x equals positive 1. When I plug 1 in, the denominator becomes 0, which means it's undefined, so this has to get crossed out. For number 10, determine the focus and the directrix. So we haven't done parabola stuff in a while. So this one has a vertex of negative 2, comma, positive 1, and a p-value. For p is negative 12, which means that p is equal to negative 3. So because p is negative, this is going to be concave down. So I'm going to draw it. Negative 2, positive 1. This is my parabola. Well, this is my vertex, I'm sorry, and it's concave down. So to figure out the focus, I follow the p-value. So I go down 3. So if I go down 3, I have down 1, down 2, down 1, down 2, down 3, right here. That point is negative 2, comma, negative 2. And then the directrix, I'm going to go 3 in the opposite direction. So now I'm going to go back to the vertex. I'm going to go up 3. So I have 1, 2, 3 right here. Remember, it's a line. This is y equals 4. Number 11, state the transformation performed on f of x. So the minus 2 tells me that I am going to the right 2. And the minus 3 on the end tells me that I'm going down 3. The second part is to sketch a graph of g of x. So it gives you f of x. It gives you the graph of f of x. So it also gives you some of these points. So I'm going to use this point here. I'll use this one. I'll take these 5. And I'm going to follow the transformation. We said it's right 2, down 3. So if I go right 2, down 3, this point right here turns into this one. I went to the right 2 and then down 3. So I'm going to take that and do that for all of them. And you can see that your parabola should still look like a parabola. I'm not going to go too far past the last point, and I'm just going to draw an arrow in the direction it's going in, and this is what g of x should look like. Okay, so I take the graph of f of x and I move it to the right 2 units and down 3 units because of what the rule says in the actual equation. 12 through 14 is the rational expression, so only multiplying and dividing will be on your test. So the way that you are going to do this is multiplication for number 12. So multiplication, you just start off right away by factoring everything. So x squared plus x minus 12 should be x plus 4 times x minus 3 divided by 16 minus x squared, that's 4 plus x, 4 minus x, times 2x minus 8 is 2 times x minus 4. And then x squared minus 9 is x plus 3x minus 3. So now I can start canceling things. You can only cancel a numerator with a denominator. You can only do 2 at a time. So I can cancel the x minus 3 with the x minus 3. The x plus 4 with the 4 plus x. Even though these they look like they're opposites, they're not, because addition, you can switch them back and forth, right? That's the commutative property. And then 4 minus x and x minus 4, you can cancel, but you replace one of them with a negative 1. So for number 12, on the top you're left with 2 and a negative 1, gives you a negative 2. Divided by, on the bottom, you only have x plus 3. So final answer is negative 2 divided by x plus 3. Number 13 is the same idea, but you have division. So the only thing that's different is you have to take the division and turn it into multiplication. Remember, division is really keep, change, flip. So keep this first fraction, you're going to rewrite this, minus 11x minus 6 divided by 2x squared minus 72 times, right, so that's the change, and then the flip is 60 plus 10x divided by 2x to the third plus x squared. So now you're going to do exactly what you just did for number 12. So if I factor the 2x squared minus 11x minus 6, that gives me 2x plus 1 times x minus 6. On the bottom, if you take out a 2, you're left with x squared minus 36, but that's the difference of 2 squares, so that's x plus 6x minus 6, times, you could take out a 10, you're left with 6 plus x, divided by, GCF is x squared, you're left with 2x plus 1. So when you start canceling things, 2x plus 1 cancels, x plus 6, 6 plus x minus 6, x minus 6. And then if you want to, you can do it after if you want, but the 10 and the 2, 10 divided by 2 will turn into 5 divided by 1. So on the top, you only have a 5, and on the bottom, you only have an x squared. So this expression is equivalent to 5 divided by x squared. And then number 14 is probably the longest one because there's a little bit of both in there. Okay, you can actually do, you know how I normally tell you, you can, whenever you multiply polynomials, you can only multiply 2 at a time. In this case, you can actually try to simplify it all at once. So you are going to do keep, change, flip on this division problem right here. So I'll change color so we can see this better. So leave this alone first of all. 9x squared minus 4 divided by 2x minus 2 times this, 15x squared minus 15 divided by 12 minus 18x. So that's your keep, change the division to multiplication, and then flip this fraction. Okay? And then it's a normal multiplication problem. You factor everything, see what cancels out. So 9x squared minus 4, that is 3x plus 2, 3x minus 2. Divided by 2x minus 2 is 2 times x minus 1. times 15x squared minus 15. GCF is 15. You are left with x plus 1, x minus 1, because you can do the difference of two squares. 12 minus 18x. GCF is 6. You are left with 2 minus 3x. Times 20x minus 4. Take out a 4. You're left with 5x minus 1. Divided by. Master product on this bottom part gives me 3x plus 2 times x plus 1. And now we cancel things out. So 3x plus 2 cancels with a 3x plus 2. 3x minus 2 and a 2 minus 3x cancels with a negative 1 left over. X minus 1 cancels. X plus 1 cancels. And that's it for your polynomials. Your coefficients, you can do it after if you want, or you can start doing it now. So I'm going to do some of it now. So 4 over 2 will turn into 2 over 1. 2 divided by 6 will turn into 1 divided by 3. And then 15 over 3 will turn into 5. Okay? You could do all of that after, though, if that confuses you as well. So on the top, I'm left with negative 1 times 5 times 5x minus 1. So that's negative 5x minus 1. And on the bottom, I don't have anything. So if you want to put over 1, you can, but you don't have to. That's your final answer. Number 14, Nathan takes 50 minutes to finish shoveling. It takes 20 minutes if his sister helps him. So this is one of those work problems. So we have Nathan plus his sister is the both of them working together. So Nathan takes 50 minutes. So 1 over 50. It takes 20 minutes for the both of them. How long does it take his sister? So plus 1 over x. Okay. You can multiply 20 times 50 times x if you want. There's actually an LCD of 100x. But if you don't use 100x, you could still get the same answer as me. So 100x over 50, that's 2x plus 100 equals 5x is my new equation. 100 equals 3x. When I divide by 3 and I round to the nearest hundredth, I get x is equal to 33.33 minutes. Okay. Number 16, a model airplane takes off at a constant rate of 15 feet per second. It gives you the equation. A of t is equal to 15t. A ball is launched from ground level. The height of the ball is b of t. Algebraically determine if the model airplane and the ball will collide. So if they will intersect is what we want to know. So I'm going to do 15t equals negative 16t squared plus 45t. Okay, so the way that you're going to solve this, they actually will collide if you get a positive real solution. If you get imaginary numbers, they are not going to collide. And if you get negative numbers, because you cannot have a negative time, they are not going to collide. So when I solve this, 0 equals negative 16t squared plus 30t. I'm going to take out a GCF of negative 2t, and I'm left with 8t minus 16. Minus 15. Whoops. So negative 2t equals 0. That gives me t equals 0. So that's right when it starts because they're both leaving from ground level. Okay, so they're at the same point on the ground, essentially. And then the other one is 8t minus 15 equals 0, which gives me t is equal to 1.875, I believe is the number. Yep, 1.875. So determine if they will collide. Yes, they will collide. They collide at 1.875 seconds. Okay? Extra help is on Tuesday after school if you have any additional questions.